Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the construction of confidence interval for a population mean when variance is unknown. So let's say your data comes from a normal population, the mean is mu, and variance population here is unknown. Therefore, the confidence interval can be constructed by using this formula here. Now, if you want to write this formula in the compact form, yes, you can, because you can see that here we have the similarity of the terms. So this one is similar to this one here, except that you have plus and minus sign. So therefore, if you want to write the formula in a compact form, it will look like this, which is x bar plus minus the t quantile, which can be found from the t distribution table, and this is s, which is the sample standard deviation over the square root of sample size n. So here is this one here is the degrees of freedom. So the t quantile here depends on the degrees of freedom, and this one is the value of alpha, where you know that alpha here is just equal to 1 minus the confidence level. So for this one, you need to divide alpha with 2, okay, as given by this one. So alpha over 2 here represents the area on the end of the tail. So this one here is on the left, and this one here is on the right. So the value of t quantile here is referring to this horizontal axis, and this is the positive value of the t quantile. And because the nature of the distribution is also symmetric, therefore this is also the same value, except that it has a negative sign to that. Okay, so as an example here, suppose you are asked to construct a 90% confidence interval. So this is the value of the confidence level, which is 90%, and can also be written as 0.9. So if the sample size used is 15, so this is the value of n, but then the degrees of freedom is equal to n minus 1. So degrees of freedom here is n minus 1, and therefore degrees of freedom is going to be equal to 14. So find the values of this t quantile here. This is the positive value, and the negative value, I'm sorry, this is not supposed to be standard normal. This is supposed to be from the t distribution table. Okay, so if we look at this t distribution table here, you can see that the area given by the table is from one point t to the right of the distribution. Okay, and area here is represented, is given by the top values here on the table, and we know that the value of t horizontal axis here, so this is the value of t, and the value here given by the table are all positive, so which refer to the value of t from 0 onwards. So these are the value of t in the table. And also, in order to use the table, you need to know another item, which is the degrees of freedom, where in this case the degree of freedom is equal to n minus 1. Okay, so I'm just going to sketch the required area for the question asked. It is to construct the 90% confidence interval, which means that this is 0.0, which means that the area in the middle here is going to be equal to 0.9. Okay, So that is the value of confidence level, and we know that alpha is 1 minus 0.9, which is equal to 0.1, and therefore this area is going to be alpha over 2, and this is also going to be alpha over 2. So 0.1 divided with 2, you will get the area here is 0.05, and this is also 0.05. So your job is to find what's the value of t here, where t is equal to n minus 1 alpha over 2. Okay, so now the since n is 15, so degrees of freedom is going to be 14. So we are looking to find the value of t 14, and alpha over 2 is 0.05. Okay, since we know the area here is 0.05, so this is the same area as given on the table of t distribution here. Therefore, what we can do next is we can just go straight to degrees of freedom 14, which is this one, and then we are just going to go refer to this line here, and we're going to refer to 0.05. so 0.05 is this one. So you will go and manage to read this value. So this is the value of t quantile that we're looking for. So therefore t 14 0.05 is equal to 1.761. Okay, so this is the positive value, and if you want a negative value, you just attach the negative sign to the same value here, because they are actually the same values, just differ by the positive and negative sign. Okay, next let's look at this example here. So we have 10 randomly selected automobiles were stopped, and the tread depth of the right front tire was measured. So this is our sample size, and the sample mean, so this is the value of x bar. So x bar was 0.32 inch, and the standard deviation was 0.08 inch. Well, although it doesn't explicitly say that this is the sample standard deviation, but we can assume that it is such because it is mentioned within the same sentence here. So basically this one refers to the sample mean, and therefore this actually refers to the sample standard deviation. Next, find the 95% confidence interval. So this is the value of confidence level, and assume the variable is normally distributed. So for this example, we're just going to apply the formula, which is given by x bar plus minus. So this is the t quantiles, and the t quantile depends on the degrees of freedom, which is n minus 1, and alpha over 2, and times with sample standard deviation over square root n. Okay, so we're just going to plug in the information here. For example, the sample mean is 0.32 plus minus. Now this is the t quantile, n is 10, therefore this becomes equal to 9, and 95% confidence level is 95%. Therefore alpha is equal to 1 minus 0.95, which is 0.05. And since alpha has to be divided by 2, so alpha is going to be 0.025. Okay, next the value of s is 0.08 over square root of 10. 10 is the sample size. Okay, so from the table you can look at degrees of freedom 9, and alpha is 0.025, so it is quite straightforward really, and you will see that the value of t quantile is going to be equal to 2.262, times 0.08 over square root 10. And punch in the values into your calculator, you will be able to get this equal to 0.0572. Okay, so therefore we can present the population mean mu to be between two values. So if you take 0.32 minus 0.0572 here, you will get the lower limit is equal to 0.263. And if you take 0.32 plus 0.0572, then the upper limit is going to be equal to 0.377. Okay, so that's the 95% confidence interval of the mean depth. Okay, now let's look at this example here. So these are the following data. So we have 3, 6, 7. So our n is equal to 7. And the question is asking you to find the 99% confidence interval. So therefore alpha is 1 minus 0.99, which is equal to 0.01. Okay, so if I sketch the graph, it's going to look like this. So this is 0. So the area between these two values here, so this is t n minus 1 alpha over 2, the positive value at this point, and at this point is negative t n minus 1 alpha over 2, and the area in between here is going to be equal to 0.99. Therefore the remaining areas, which is this one here, is going to be 0.01 divided with 2, which is 0.005. So similarly, this one is also going to be equal to 0.005. Alright, so from the t distribution table, I hope that you will be able to get this value. So this is going to be t n minus 1 is 6, alpha over 2 is 0.005. And this will be equal to 3.707. So you can try and do it on your own. I'm sure you'll be able to get this value from the t distribution table. Right, next we are going to apply the formula. So the formula here is going to be x bar plus minus so the value of t, I'm just going to write down straight, 3.707 times with s over square root n, so n is 7. So now we need to find what is the value for x bar and s. So for x bar, it is very straightforward. You just need to add up all these values here. For example, 5460 plus 5900 plus 6090 plus ... and the remaining value is 9930 over 7, and you should be able to get the answer is equal to 7041.43. so that's the value of x bar, and the value for s squared, okay, or s. Okay, so I'm finding the value for s squared, and for this one let's try and use the alternative formula, which is given by xi squared from I1 until 7 in this case, because we have 7 values. Okay, and then for here is going to be from I equals to 1 till 7 xi squared over n. This one is over n minus 1. So this is the alternative formula to calculate the sample variance. Alright, so basically what it means by this one is you are going to square each value of your data. For example, 5460 squared plus 5900 squared plus blah 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 until 9930 squared. So you get the sum of that values, okay? And for this one, this is basically you have to add up all the values. So this one you have to add up first, which means 5460 plus 5900 plus blah 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 9930. So once you add them up, then only you square it. So that's the meaning of this process over here. So by doing that, I believe that you should be able to get the answer of s squared is going to be, okay, I'm going to write down s squared here is going to be equal to 2592,980.952. And therefore you need to find what is s. S can be found by taking the square root of the variance of the sample variance, and you will get that the sample standard deviation is going to be 1610.2736. Okay, so just plug in the value inside here and the mean value for this one over here, and you will be able to get the answer for this example 2.0. So I'm just going to give you the answer here. So final answer is going to be equal to 4785.25. So the mu is between this value and 9297.61. Okay, so go on and try to get these answers on your own. Alright, I think that's all for now. Thank you very much for watching.